right, good morning. Today we start over on another topic, a new chapter. Okay, please take a book and it's Unit 15. It's Unit 15. One student not here. Who is he? Now let me check the attendance first of all, because I found one student's not here. And while we are waiting, please take a quick look on today's topic. Is on chapter 15. Something on calculation, something on explanation. Let me see. 陳許廷、陳學嘉、鄧家傑、何偉林、林俊軒、林成漢、李佩肯、鄧俊熙、鄧浩群、黃俊熙、黃奕郎決 And here comes 陳樂明、張思維、家謙、何麗賢、郭俊熙、羅漢力、李卓、梁家傑、澤星、李健樂、馬家樂、吳文一、譚君柔 Are you here? 譚君柔、黃成軒 Okay, 譚君柔 not here. Do you find him in the in period 3 or period 2, period 1? 譚君柔. Anyone who see him? You saw him in the previous lesson. Okay. Now, anyway, we'll go back to this. The book, can you see that? It's 15. It is on molarity, pH scale, and strain facts and alkalis. It seems those information are a little bit fragmented, but some of them they are interrelated. Okay, some of them, they are interrelated. So it's on chapter 15 on your book, page 44. Okay, 44. So it's time to get to know more about the calculations part. Okay, if you want to know something more of pH, you need to know how to calculate the concentration of something. Okay, concentration of something. So in concentration, they will tell you how much solute is dissolved in a certain volume of solution. The descriptive words to describe the concentration is concentrated or dilute, right? It is somewhat descriptive. But it is just qualitative, but not quantitatively describe it. So in chemistry, we would consider it as the molarity or the molar concentration. Now, the unit for this is the number of moles of the solute dissolved in 1 cubic decimeter of the solution. So what is meant by decimeter? Decimeter means 1,000 cm cube, okay, or 1 liter, or 1,000 liter, 1,000 milliliter. So deci means 1/10, okay, 1/10 deci. So it is just a transformation of the data from the conversion of units, okay. So the units for this is mole per dm cube, underline the term mole per dm cube, or capital M, molar. So very often we would use this more often in your DSE, okay? But in your chemistry lab, you use it simply because it's to tell you the concentration of those chemicals before you use. Most of the time, while you go to the chemistry lab, you will see this. Okay, M, 1M, 2M, 0.5, 0.2. Okay, to tell you this information. So if you want to talk about the difference between them, it is if you want to talk about 2 molar, what is meant by that? 2 molar. The 2 moles of copper 2 nitrate, for example, dissolved in 1 dm cube of solution, we will call that 2 molar. Okay. So this is what you may know. For example, if you want to get 1 mole of copper 2 nitrate dissolved into 2 dm cube, we'll call it 0.5 molar, or 0.5 mole per dm cube. It's a very simple calculations. So this is what I'd like to share with you this one. This is the third equation. This is the third equation that you need to get to know. The molarity of a solution equals number of moles over volume. So solutes over the volume of solution. So which means that given the molarity of a solution and the volume of a solution, we can project how many moles of the substances are found inside. The substance what we are now referring to is solute, 溶質啦, okay? The one to be dissolved. Okay, can you get the point? So you may use this transformation to tell number of moles of solute equals volume of solution times molarity of solution. Okay, it is just another representation of the same equation. Okay, and we try to have a warm up. Class practice 15.1. What is the concentration in mole per dm cube of solution of sodium carbonate that contains 47.7 gram of solute in 1. 1.80 dm cube of solution. So simply division of 47.7 gram to 1.80 dm cube doesn't help, right? Because it tells you the unit of concentration only, the normal concentration, but not the molar concentration. Let me clarify with you here. For some people, you may see the concentration they are of this unit as well. Now, it is the normal concentration of a solution in terms of gram. They represent it as a mass of solutes. Okay, mass of solutes, but it doesn't tell you the molarity, the molar concentration. So they are of different concepts. Okay, so in our DSZ, we usually express concentration in mole per dm cube instead. So for 15.1, question 1, can you manage to do that? So what should be the answer? So in order to calculate the molarity of sodium carbonate solution, you need to express it as number of moles of sodium carbonate over the volume of solution. So the numerator this time you cannot find it, right? So you have to solve it now.譚君又咗嚟。So the first thing that you need to do is to write the number of moles of Na2CO3 first from the given data. How? Mass over molar mass. Okay, so over molar mass of sodium carbonate. Now, so you may find which is what? 47.7 gram. So it is used as a molar with that molar mass of sodium carbonate. What is that? What is the sodium? What is that data? It's 106.0. Okay, 2 sodium, 1 carbon, 3 oxygen. So you may get it as 0.450 mole. So afterwards, you may get this data and put it directly. 0.450 mole over the volume of solution. This time is 1.80 dm cube. So you may get it as, what is that data? 0. What?譚君佑, do you know the answer?
0.25咯。
0.25 accuracy please.
0.25
Yes, the significant figures is 0.250 molar. So please check your the significant figures. Okay, so the unit for this is mole per dm cube. So which represent mole per dm cube. But in science, we would express it as dm minus 3 to tell per. Second is about the significant figures. So in this calculation, we come 1, 2, 3, 1, 2, 3 sigfig. So the answer should be in 1, 2, 3, 3 sigfig. Can you get a point? Now, even though for this is 1, 2, 3, but here comes 1, 2, 3, 4, the accuracy they will go back to 3 sigfig only. Is that clear? So this is the number 1. Can you do the same by doing question 2 and 3? Question 2. Something similar, right? Isn't it? But this time I do the whole equation in reverse. So you will be given the molarity and the volume of a solution. The solute is so potassium hydrogen phthalate. Okay. So it is a very complex substances. So the mass of a sample. So that is our task. So the first one is to find out number of moles of the Ch.15 So you may find it as the molarity of the solution times volume of solution. So molarity is 0.0280 mole per dm cube, while the volume it is 250.0. You write it down as cm cube, right? But once I mark it like this is problematic. You need to change the form of cm cube such that it is in line with dm cube. And by doing so, you can get the answer as mole. Can you get a point? So what should we do? What should we do? It's not in cm cube. I change a little bit.除一次啱啦。So you're going to times 10 to the power minus 3 dm cube in order to get the answer. So this is what the trick is. Okay, divided by 1000. And finally, what you can cross out those dm cube, and here comes mole. Do you understand? So the answer is what? The answer is what? 記得
1.43
1.43未計完，我計緊毛就係啦。1.43都冇 unit 都唔知你。
0.007
係0.007啊，00或
0.007
係啦，0.00700或者係7.00乘10嘅負3毛，得唔得？While the mass of Ch504K can then be found. It is found as the number of moles of Ch504K times what? Times the molar times its molar mass. (7.00) times 10 to the power minus 3 mole times its molar mass, it is 204.1 gram per mole. And finally, here comes the answer, 1.43 unit gram Okay, it is the mass of sample. So you know that mass of sample. Okay, is that clear? Any questions so far for this part? Now here comes question 3. 睇到未呢度？ If that is okay, here comes question 3. For question 3, that is something else. We've got 20.0 cm cube, 1.00 molar of KCl. Get mixed with 30.0 cm cube, 2.00 molar K2SO4 solution. So what is they want to calculate the concentration of K plus AQ in this mixture. So you may see I put a very strange bracket, the middle bracket here. Now, I would like to introduce this to you. What is that? If you see such, which means molarity. So you will use this very often in Form 5 and even Form 6. So you will use this sign, molarity. Can you get the point? So in order to get to know this data, so you know that it is the molarity of potassium ion, which is equal to the total number of potassium ion, number of moles, sorry. I would omit this word, number of moles of potassium ion plus over the total volume of solution. Okay, so this is what you are going to do at the beginning. Total number of moles of potassium ion and the total volume of solution. Okay, this one is easy. 20.0 plus 30.0 times 10 to the power 3 dm cube. Here comes 50.0. 10 times 10 to the power minus 3 dm cube. How about total number of moles of potassium ion? How? You use the words molarity times volume to get the answer, right? You use this, okay? This is the formula. So you are going to have it as what? M times V. V plus M times V okay? And you can cross out those terms and you can get mole. So what is the total mole of substances? What is the total mole? Is it correct? Is it correct?
唔係好似 K2SO4
差個
有
2好似差
兩個
唔多
Ki 人噶嘛
Which one?
後面嗰個
？K2SO4
Yes, that's right. Can you see that? K2SO4 here. We've got 2, which means that this one you have to times 2. Why? 1 mole of K2SO4, they will contains 2 mole of potassium ion. So this is what you have to consider. Well, this one is just 1-to-1. 1 mole of KCl, they will contains 1 mole of potassium ion only. So that 2 is a tricky point here. So you are going to times 2 here in order to get the answer. So you will get it as 0.120 mole, while the former case is 0.0200 mole. Okay? 呢兩個加咗去 So what we get? 0.140 mole。咁喺呢度乘以都係俾人陰咗啫，記住啊，0.140 mole over the volume of solution is 50.0 times 10 to the power minus 3 dm cube becomes 2.80。計咪到 So that is the answer. So be aware of the tricky point of K2SO3, the 2 here. If you have got 2 molar of solution there, which means that we have got 4 molar of potassium ion in the original mixture. Is that clear? So this is somewhat is rather tricky to very, very tricky. Now, if you have no more problem, we come to the next part. Is about the indicators and as well as pH scale. So you turn over to page 48. 識計埋呢度。Let me know your status. You will know what's happening. You will understand what's happening. Please put a tick. If not, across. 我想知你大家搞翻掂。得一個 tick 啫，2個、3個、4個。有扎街坊唔知去咗邊啦，係咪冧咗檔啦已經？係有人舉手，唔知做咩，係咪有嘢想問？陳許廷、何偉林、李貝恒、鄧俊熙、黃奕朗、謝學明、張思維、何孝仁、郭俊熙、羅康力、李晴、梁家傑、李澤星、李健樂、馬家樂、譚君柔、馮家謙、文俊滔，知唔知做緊乜？明定唔明？好，其餘嗰啲去咗邊？凍僵咗啦。要做呢啲題目嗰陣時，就係用一條 equation 咯，做一條formula。呢條 formula 係咩啊 ？Molarity 等於 number of moles of solute 溶質啦，除 molarity overall volume of solution。Okay, so you use this and together with some other formula in book 1, mass over molar mass equal mole. okay, and you use this as a start, and you try to have the calculations in an integrated manner. Okay, is that clear? So we come to the following. You take a look at the book again. Here. Okay, we come to the book again here. So we come to the indicator. Now, indicator, it is used is for us to get to know the acidity or the alkalinity of a solution. I just introduced to you those chemicals as said before, right? Limus is a dye from lichen, and it will change its pH. It will change its color upon different acidity and alkalinity of a solution, but it doesn't tell the exact the pH of a solution. Similar case while you use it in methyl orange and phenolphthalein. Okay, so these two is rather strange. Having this item here is a little bit ambiguous to you. Now, so remember, please add that working range of pH. So for methyl orange, the working range of pH. So mark it down. So we have got the pH here, pH range. We have got 3, 5, and that is red, orange, and yellow on here. While orange, it is a mixing of the two dyes. One is red, one is yellow. Okay, so that that dye is very interesting. They would changes in color in different pH of a solution. So they will change the form a little bit. Once I change the form a little bit, the structure is a different. They would have a different ability to absorb the color, okay, from the visible light. So it will give you a different color. Something about related to physics, okay? But don't worry, I just introduced you what is that, okay? Phenolphthalein is another one. The pH working range of this is 8 to 10. Monoamine is here, right? So 8, 10, and here is pink, greater than 10. Here comes red, smaller than 8. Here comes colorless. So using these two, or even limits, how about limits? Have I told you? Have I told you last last time about limits? 有冇講到 ？Page 5, page 8, 14 is purple, it is blue, is red, respectively. So if you did the solution and if you use the pH paper, litmus paper to test its exact pH is rather problematic. And one more point I would like to remind you is on the technique here. Now it is for the visual effect only. Please don't do this action. You know why? The dye will dissolve into the whole solution and contaminate. Okay, so you never do this action. Instead, I would use a blue litmus paper, for example, and I drop the sample to it. Okay, and you can easily test it is whether it's acidic or alkaline, or not acidic, or alkaline, or not acidic. Okay. So not acidic can be neutral, or it can be not so strongly acidic, highly acidic. Okay, you may see that if the solution is just pH 6, okay, they will give us the color to purple. So not obvious. So that 3 is just the drawbacks, the limitation of having these 3 indicator. Okay, how about universal indicator? It gives a various color in different pH. So it's a better choice if you get to know the pH. So it's time to get to know what is meant by pH. In Form 2, nothing is told about this P and H. What is that? Why is it P and H to come together? And why is it small letter P and capital letter H? Now it's time you get to know the meaning. P, H, 細階 P, 大階 H. Okay, so P here means negative log, while H here it is the molarity of hydrogen ion. So you would, besides having pH, we have got POH. Okay, and P here, we have got different calculations later on, just like equilibrium, we've got the K constant, we've got the pK value, okay, or pKa value, for example. So you will know it later. You will know it later about this. So pH, remember, starting from today, remember to put a small letter P, capital letter H to tell. And it tells you the extent of the concentration of hydrogen ion in the solution. The concentration of the hydrogen ions can be, and why do we need to use pH scale? Why? 咁煩嘅？點解我無端端明咁我不如直接話講 hydrogen ion concentration 咪得咯？做乜咁煩嘅？ Why do I need to use negative log scale or log scale? Why? Now, it's because of the concentrated solution, it ranges from 1 molar to 10 to the power minus 4. Very large. How large it is? Now you turn to this page and you can get what I mean. On page 52, indeed, you are now handling the concentration of ions with a large range of concentration. If you talk about pH is equal to 0, it's just 1 per molar. But if you talk about pH 14, it is just 0. Can you count? 0.130. Here comes final number 1. If you want to compare the solution of different pH, you may find it problematic because you are now dealing with the solution of very great diversity of hydrogen ions. So it's time to make a log scale. Can you get a point? However, while you handle the solution is rather dilute, so if you just make a log scale to tell hydrogen ion concentration, it will always give you a negative number. It will give you a rather confusion to get to know which one is more concentrated. The more negative value, which means the smaller the number, right? So it is tackled by putting negative log instead. 明明點解要負 log hydrogen ion concentration 啊？明唔明啊？點解要負啊？首先第一樣嘢 solution 咧，我哋嗰啲濃度咧就咁酸啊鹼啊嗰度咧可能係1個 molar 0.幾 molar 咁樣等等。我哋牽涉到咧佢哋本身個 solution 啊，可能大家都1個 molar，1個 molar 嘅 HCl 同1個 molar 嘅 NaOH 咧，佢哋個 pH 值咧已經爭好遠㗎啦。知唔知啊？1個 molar 嘅 HCl 你知唔知有幾多 pH 啊？我哋諗識唔識計？1個 molar HCl Hello， 識唔識計？有冇識計？靜晒添，一個 molar 嘅 HCl 即係幾多 ？pH 啊嘛 ，pH 即係負 log hydrogen ion concentration 啦，係咪？即係幾多？1 mol 嘅 HCl 有1 mol 嘅 hydrogen ion 啦，係咪？咁即係 pH 唔敢講，係啊，真係唔敢講啊，零喎，原來真係唔敢講零。咁但係一個 molar 嘅 NaOH 咧，點計啊？因為我一定要知道咧，佢入邊佢即係話佢負 log hydrogen ion 啊嘛。咁但係佢嘅 hydrogen ion 即係有幾多咧？我唔知嘅喎。我乜咪得 hydrogen 冇 hydrogen ion 嘅咩？唔係㗎，水咧原來係入邊係有呢一個嘅hydrogen ion hydrogen ion 啦，同埋 hydroxide ion 嘅，係有嘅，兩樣嘢都有嘅。OK， 好。咁點算？我哋試下咁樣計先啦。我調翻轉計，你應該識計。但係調翻轉，我有數，我計 hydrogen ion 知，但係我而家要知咧，佢真正 hydrogen ion 有幾多啊？嗱，呢下麻煩啦。咁所以我哋一定要知多少資料嘅。嗱，譬如第一條，我哋實習一下先啦。pH 呢度，呢個 pH of acid 呢個易搞啦 ，HCl 嘛，咁又係啦，1 mol 嘅 HCl 入邊有1 mol of hydrogen ion。OK， so we know that 1 mol of HCl they will ionize to give 1 mol of hydrogen ions. So you may know that the pH of HCl in this case is minus negative log of hydrogen ion concentration, which is negative log. You simply put this into the data 0.0500. Okay, so we have got negative log. So here comes the answer. What is that?
1.30。
1.30。咁所以點解要知唔知道有個負啊？你唔負咧就麻煩啦，因為原來我計緊一個，但呢啲嘅 acid 嘅濃度都好常見啦，係咪啊？但係你唔整個負 log 嗰個負咧，咁你嗰個數咧就會無端端係負數啦。咁你就仲麻煩，好難比較。咁我哋要咁就，咁有冇單位㗎 ？No units。pH 係冇單位嘅，得唔得 ？pH 係冇單位。所以咧唔好懶醒啊，唔好喺度寫 molar 啊，寫個 molar 落去就炒粉㗎啦，因為你唔會將嗰個 log 咧 log 埋個單位嘅，所以唔好寫單位落去啊。第二條咯 ，calcium hydroxide solution that has pH of 11.8 3.9. What is the concentration of hydrogen ions in the solution？ 咁點做咧？點計翻轉頭？我知道 pH 係等於 molarity of full negative log molarity of hydrogen ions, which means that negative log hydrogen ion concentration pH, right? It is equal to 11.9. You can do that in reverse, which is equal to 10 to the power minus 11.9. Okay, you get the point. So how would you get that data? Is that from this equation, hydrogen ion molarity is equals 10 to the power minus pH. Okay, so you use this and to calculate that follows. So you type the calculators and you may get it as 1.26 times 10 to the power minus 2 mole per dm cube. In this, is that clear? So go back to the, I would like to head it towards the same question. Now, if you study the pH, we usually you use this to tell the range of the pH scale is from 10 to 14, okay? But you may have the value E below 0, okay? Or even larger than 14. So remember, but that represents already a highly acidic or highly alkaline medium respectively. Form 2, when you are studying Form 2 IS, we usually tell you pH equals 7 means the solution being neutral, right? Exactly 7 is neutral. Smaller than 7 is acidic, larger than 7 is alkaline. But remember that that condition, you are going to carry out the measurement at 298 Kelvin. If a slight change of the temperature, the pH cutting line, right, to tell you acidic and alkaline may be different. Remember, the pH value equals 7 being reflecting the solution being neutral is done by the measurement at 298 Kelvin. If you have high temperature, if you have lower temperature than 298 Kelvin, the cutting line to tell you that it is a neutral acidic alkaline may be different. Okay, so what is the hidden message? You are going to tell you that saying, of course, you know, the lower the pH, the more acidic the solution is. The higher the pH, the more alkaline the solution is. It's 200 we will use the word about 25 degrees Celsius. It is roughly the same. Okay, you use 25 degrees Celsius to tell. Of course, you will want to tell is minus 207, 273.1 something. 115 is an absolute zero, right? But we usually express it at 25 degrees equals 298 Kelvin in DSE. Okay, so it is related to something about the that equation. Indeed, water we've got pH 7, which means water we have got the hydrogen ion concentration minus 7, 10 to the power minus 7, right? But we will say that as neutral. Isn't it rather strange? We have got hydrogen ions, but we will say they're neutral. What is the hidden message? We would also have the hydroxide ion concentration the same in order to say the neutral. Okay, why? Because you have got these equations. The pure water will slightly ionizes into hydrogen ion and hydroxide ion with that equation. So if you have got one molecule of hydrogen ions, they will have a very slight percentage of hydrogen ion and hydroxide ions to be formed. So but once there is that ionization, they will have it in 1-to-1 ratio. Okay, which means that they are equal in their concentration. Can you get the point? And if you want to tell the solution being acidic, our comparison is to check whether or not the hydrogen ion concentration is larger than hydroxide ion concentration. And we will do it in reverse to judge it if the solution is alkaline. Remember, all those measurements is done it as 25 degrees Celsius or 298 Kelvin. If I want to increase the temperature, what will happen? That equilibrium will be changed, it will be disrupted. So by having more hydrogen ions to be produced and together with hydroxide ions, like this when temperature is higher. Why? Actually, what is happening? You are going to break the bond. Of course, you know, you can get what I mean, right? So when temperature increase, more water molecules will have a higher chance to undergo ionization to form this. But you will keep the hydrogen ion and hydroxide ion still equal, right? So for example, if you've got pure water, I heat it to 50 or 60 degrees. So it's still neutral. But if you measure the pH value, what will happen? The pH value will drop. Can you get a point? So it is not a strange thing if you describe the pH equals 6, for example, being neutral. Now, so if you want to tell such phenomenon, the way to compare is to tell me, first of all, what is the temperature of measurement of the pH of a solution? If the temperature is high, there may be a chance. Having the pH smaller than 7, but you still tell it as neutral. Can you get the point? Can you get the point? So what is the hidden message? If you have got 25 degrees, we have got this data, okay? Which means that if you want to get to know the pOH value, so what is that? It is 14 minus pH. Can you get the point? So why is it 14 minus pH? 14 here. It comes from that hydrogen ion concentration times hydroxide ion concentration. On here comes a constant. So I start from this. So that constant, it is what we call it as somewhat a very difficult term. So we call that equilibrium constant. You will know in Form 5, Term 2, we call it equilibrium constant, Kw. So pOH can be calculated as pH 14 minus pH. And I use this to calculate this question. 1 molar NaOH, what is the pH? So you get to know what is the pOH, right? Yes, it's 14. Can you get the point? So it is based on the assumption that 1 molar of, we have got 100% dissociation of NaOH in water to give hydroxide ion. That is, make it as an assumption like this. Now, otherwise you cannot calculate. Is that clear? So we use this range of the pH from 0 to 14 to visualize it, because although the theory behind is rather complicated, to layman, we seldom we seldom find some time to understand this. Instead, we try to use something visual. Color chart can help. I use color chart, right, to tell you the corresponding acidity or alkalinity of this. This time we use universal indicator. It is indeed the mixture of indicator. It changes its color. as you said, the natural dye, for that one, the color of it will be very dull. They will have a changing in color in that 3 colors only. If I get mixed, we have got various the changing of color. So you use this for account to measure the correct pH of the test. For the household chemicals, just like disinfectant, drain cleanser, bleach, ammonia, they are of high pH. Baking soda is of high pH as well. Milk, slightly acidic. Pure water, pH 7, or slightly acidic. Rainwater, unpolluted one, but acid rain is more acidic than 5.6. Coffee, tea, fruit juice, stomach acid, lactic acid bacteria, vinegar, all those acids acidic. Okay, is that clear? So besides, you may also use pH meter. pH meter, it is a glass electrode. Inside that, we have got 1 molar hydrogen ion concentration of it is HCl, and I would have the sample here, and you are going to compare the difference in hydrogen ion concentration that will reflect as the data here, and they'll tell you what is the pH. They'll give you a meter, give you a reading of this. You may also use pH sensor attached to the data locker to help. Okay, how about this? It's easy, right? pH range of a saliva, the indicator should be pH yellow when it enters the sample saliva. pH range is about pH yellow. It's 4 to 6, right? It's 5 to 6. So what does the pH range tell you about saliva? This is weakly acidic. But the oven cleanser, if it changes the inverse indicator purple, which means the pH is becoming 13 to 14, the solution is strongly alkaline. It's highly alkaline. Okay? Can you get a point? Okay, so we try to stop it here, right? Because this one is more complicated. So in short, our conclusion about today's lecture is to get to know 2 important items. One is the concentration of the solution in chemistry. We represent it as molarity. Number of moles of solute over volume of solution. While for the pH value, it is calculated as negative log hydrogen ion concentration. You may do it in reverse to calculate hydrogen ion concentration. It's done by having 10 to the power minus pH. pH equals 7 telling you the solution is neutral is based on the measurement at 298 Kelvin. If you have got a higher temperature, okay, if you've got a higher temperature, the pH may change. The pH cutting line may be changed. So remember, so the way to judge whether the solution is acidic or not, you better stick back to this model. Okay, if you are going to compare the relative hydrogen ion concentration when you compare with those of hydroxide ion concentration, if they are equal, neutral. If hydrogen ion is more overwhelming, acidic. If it is quite the opposite, it's alkaline. Is that clear? Okay. Questions? Questions? What do you feel about this? Now let me know if you understand the similar concept of this. So for MC question 2 and 7, they are suitable for you to do it now. Okay, so you spend some time after this lesson to finish those MCs. Right, for the first few 1, 2, 3, 4, 5, 6 MCs, they are suitable to do it. MC 2 to 7. What I mean is 2 to 7. MC 2 to 7. Please do it at home. 2 to 7. Okay. Okay. All right. So I would like to stop here and see you guys next lesson. Bye bye.